Okay, in the last video, we introduced the method of using trig substitutions to solve different types of integral problems, and we discussed some of the working principles that's involved with the technique. So far, though, we haven't solved any problems, and that's what we want to be doing now, beginning with this video. Here, we're looking at the integral of dx divided by x times the square root of x squared plus a squared. So the first thing we want to do is decide which one of our basic trig identities do we want to invoke here to solve this problem. And we're looking here, we've got the square root of a constant squared plus variable squared. So the trig identity that resembles that is this one here. We have a constant plus a variable squared. So we start the process, we say let x be equal to not just the tangent of theta, but because we have this a squared here, we would say a times the tangent of theta. So when you substitute that in this integral sign, we're going to have a squared plus x squared, which is now this, a squared tangent squared theta. And we can factor the a out of this and take it to the outside of the square root sign. That will give us a. And inside of the square root sign, we'll have 1 plus tangent squared of theta. That's the secant squared of theta. We're going to take the square root of that. So we get the secant a times the secant of theta for this part of the integral right here. So this becomes a times the secant of theta, and here we have x, but we already have a substitution for that. So what will dx be? So we go to here, dx will equal a, and that will be secant squared of theta d theta. So it looks like all the pieces are in place here. We can go ahead then and transform this integral into a trig type integral. dx, that's this, we have a secant squared theta d theta divided by x, that's this, a times the tangent of theta. And then we also have this, which is this, a times the secant of theta. And let's see what this gives us. A divided by a squared, that's 1 over a, it's a constant, we'll take it to the outside. These are going to cancel, so it looks like we have the secant of theta divided by the tangent of theta d theta. So when we use this substitution, this integral here is now this integral. So instead of having to solve this integration problem, we have to solve this integration problem. And let's see, it doesn't look like a u-du substitution is going to work here. Let's see if we can simplify it. Let's just use the basic definition, see if we can get lucky. Let's see, this would be equal to 1 over a, the integral, the secant of theta, that's 1 divided by the cosine of theta, tangent of theta, that's the sine of theta divided by the cosine of theta, and that's the denominator, so if we take it up, that would be multiplying by the reciprocal. So we have this, and it looks like the cosines here will cancel out. And so now we have 1 over a, the integral of 1 over the sine of theta, that's the cosecant of theta d theta. So with this trig substitution, our original integral is now this integral, and this one we can integrate. Hopefully you remember what it is. Let's see, this will be minus the natural log of the cosecant of theta plus the cotangent of theta, so this will be minus 1 over a natural log cosecant of theta plus the cotangent of theta. So this is the solution to this integral. Of course, we got this integral. This integral was derived from this one, and we solved it. But naturally, we have things expressed in terms of trig functions. Now we want to re-express things in terms of our original variable x. So we have to go back to our substitution here. And we say, well, the tangent of theta, that equals x divided by a. So at this point, what you do is you draw a triangle. And if this is theta, and the tangent of theta is x over a, let's get our triangle here. Everything is expressed in terms of thetas. Here's our original substitution. So we draw a triangle, the angle theta, and the tangent of x, or the tangent of theta is x over a, and that's equal to the side opposite divided by the side adjacent. So we know what this side is going to be. That's a squared plus x squared. So we can use the triangle now to convert these trig expressions and get it back into the variable x. Here we have the cosecant of theta. Now, the sine of theta is the side opposite divided by the hypotenuse. The cosecant of theta is going to be the hypotenuse divided by the side opposite. And the cotangent of theta, the tangent of theta is this, the cotangent of theta is going to be a over x. And here's our expression here, so this will become minus 1 over a, the natural log of this plus this over a common denominator. So we have and at that point we're finished. So you can say this integral here dx divided by x times the square root a squared plus x squared equals minus 1 over a natural log square root a squared plus x squared plus a divided by x plus an arbitrary constant. And that's our answer. So, again, what we do is we look at the original integral and ask ourselves, which identity is of these apply? This one, that determines how we're going to do our substitution. We follow through with the substitution, transform our integral into a trig integral, which eventually became this, which we could solve, and go back to our original substitution to construct a triangle, so we can use the triangle to convert this into the x variables and get this, which is the solution to our original equation, or to our original integral. So that's it for this problem. Come back and join us for some more videos, and we'll try and solve some more problems.